If I look at this one, so once again, I can tell that this thing is a rhombus, and it's a rhombus because we have these guys right here, all these sides being congruent. Okay, so since all those sides are congruent, I know this thing is going to be a rhombus. And now from here, I can find the area, and really there are two ways to find the area of this thing. Okay, one, because it's a rhombus, that means it's a parallelogram. If it's a parallelogram, I could just do base times the height. Ready? Area equals base times the height. So for this one, well, for a rhombus, the base and the for this one, I want to find the approximate area. And notice for this guy, this is a rhombus, and I can tell it's a rhombus based on the fact that all the sides are the same. Okay, and so because it's a rhombus, it's also a parallelogram, that kind of thing. And so right away, I could use, there's two formulas that I could use here, all right? I could use area equals base times the height because it's a parallelogram. That's what a rhombus is. The problem is here that to measure the height, I'm going to have to draw a perpendicular line here. And I don't know if there's a great way for us to be able to try to find that height. Okay, and so this is why it's nice for a rhombus to have two different methods for finding the area. So I could also do 1/2 the diagonals being multiplied. Okay, and so just being able to use two different methods could make this one a lot easier. It's really hard to find the height on this thing, but finding the diagonals, because it's a parallelogram, the diagonals bisect each other. So this piece is 5, this piece down here is also 5. I already have one of these diagonals. So this diagonal right here, well, that's going to be 10 units. So I'm going to call that diagonal 1. It's 10. Now I need to find the other diagonal. And once again, because it's a rhombus, remember the rhombus? This comes together at a 90-degree angle, which means, once again, my Pythagorean theorem is going to come to the rescue here. If I have a right triangle right here, I can find the missing side by doing the Pythagorean theorem. So down here, I'm going to call this side A, so I'm just going to call it a squared plus b squared equals c squared. And I go ahead and solve this. I'm going to subtract the 25 from each side. I like to use a different color when I subtract things from each side. And now from here, notice it did say to find the approximate area. Well, because I'm going to have to take the square root of this guy, and that's not going to give me a nice, neat value. All right, so let's use my calculator to go ahead and punch this in. So let's see, the square root of 39. So I've got about a 6.2. We'll just round it off to 1 decimal here. And so when I bring that back up here, that's this missing piece of this diagonal right here. So this is a 6.2 meters for this guy. But once again, because it's a rhombus, the diagonals bisect each other. So that means this is also 6.2. And now using some of my other properties, segment addition specifically, I now know that that second diagonal is a total of 12.4 meters long. Okay, and so now from here, I can plug it into this formula. Area equals 1/2, multiply those diagonals. And again, this is a job for my calculator. And so what I get is approximately 62 square meters. Okay, and it's approximate because I had to round off a value that I used to get this thing. Okay.